This is part 4 of the series Parallel and Perpendicular Lines, and in the last part we talked about the 4 different theorems related to parallel lines and transversals. We looked at the corresponding angles postulate, the consecutive interior angles theorem, the alternate interior angles theorem, and the alternate exterior angles theorem, and we went through proofs of several of those. In this section, we're going to start to use those theorems to figure out how to solve problems. So to begin with, here we have a problem, and we can see we have 2 parallel lines cut by a transversal, and we have 2 expressions given in 2 of these angles. Now the first step is to identify what are these angles. Well, we can see that these angles are on opposite sides of the transversal and they're inside the walls of the fort. So these are alternate interior angles. And we know from the alternate interior angles theorem that if 2 parallel lines are cut by a transversal, then the alternate interior angles are congruent. So if these angles are congruent, then we know that their measures are equal. That means we simply set these 2 expressions equal to each other and solve for x. So that's what we're going to do here. 6x minus 4 equals 3x plus 5. Now you can solve this any way you want. I like to combine my x terms first, and I like to combine them on the side that's going to make the x terms positive. So they're going to be positive over here, so I'm going to subtract 3x from both sides. So we have 3x minus 4 equals 5. I'm going to add 5. 3x equals 9, and then divide by 3. X equals 3. Now, the question asks us, use the information in the picture to find the value of the variable. It didn't ask us to find the value of the angles. We could do that. That's all we'd really have to do is just substitute this in here to find the measure of the angles. But there's the value of x. And that's really all there is to these problems. So the first step, classify what you have, determine what the angle pairs are, and then figure out how to answer the question. In this case, it was simply setting the expressions for the angles equal to each other. Let's work another example. Here we have a slightly different example. We're given this exterior angle as an expression of x, and this interior angle as an expression of x. Now there's no direct angle pair that associates these 2 angles, but with our knowledge of the different angle pairs, we should be able to come up with one to determine it. Well, I know that if this is 2x, this angle corresponds to that angle, so this angle must also be 2x, because if 2 parallel lines are cut by a transversal, corresponding angles are congruent. So I know that if this is 2x, this has to be 2x as well. So we can write in here 2x. Now, there is a relationship between these 2 angles. And you can clearly see that this is a linear pair. And as we know from the linear pair postulate, linear pairs are supplementary. So this angle plus this angle add up to 180 degrees. And so we can set up that relationship. What we have is x plus 3 plus 2x equals 180. And now we just solve for x here. So let's combine our x terms. We have 3x plus 3 equals 180. Subtract 3 from both sides. 3x equals 177. And divide by 3. So x equals 59. Now there's other methods that I could have used to solve this problem. I could have said that this and this are vertical angles, so they're congruent, and then these 2 are alternate exteriors, so they're congruent. Or I could have jumped directly to supplementary and said these 2 angles are a linear pair, therefore they're supplementary. So this angle is 180 minus this angle, and then set this equal to this. There's any number of ways you could have done it. So you're just going to have to find your own rhythm and your own style when you work through these problems to find the method that's comfortable to you based on your unique knowledge of these angle relationships. All right, let's work one more problem. In this problem, we have a slightly different setup. And here we have two exterior angles, but they're on the same side of the transversal. So these are not alternate exterior angles. Well, as usual, I have a number of different ways I can proceed. To me, the easiest way that I can see is that this angle and this angle are corresponding angles, and these two angles are a linear pair. So I know that this angle is going to be 180 minus this, because this and this add up to 180 degrees. So that's all I really have to do is subtract this from 180, and that gives me this angle measure here. So that angle is 58 degrees. So I can go ahead and write that in. So that's 58. Now, that's all I have to do is say this equals this. So 4x plus 6 equals 58. Let's subtract 6. 4x equals 52. And divide by 4. So x equals 13. So that's a simple set of examples of how to use parallel lines and transversals. Now the next thing we're going to do is we're going to take a look at how to show that two lines are parallel, given two lines are cut by a transversal. And there's a set of things that we can do there using the converse of the four theorems and postulate that we just looked at. So let's start in with that. So here we're going to be proving that lines are parallel. And the first thing we're going to look at is the corresponding angles converse postulate. If two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. Remember that the corresponding angles theorem gave us that the two lines were parallel and said because the two lines were parallel, the corresponding angles must be congruent. In this case, we're saying that if two lines that aren't given to you as parallel are cut by a transversal, but you are given that the corresponding angles are congruent, then you must know that the lines are parallel. And the proof of this is basically the same as the proof for the corresponding angles postulate, in the fact that by transformation we can slide this down and see that this angle must be the same as this, and this line must be parallel to this if these two angles are in fact congruent. So that's the idea here. So that's the corresponding angles converse. Again, we're not given that the lines are parallel, we're showing the lines are parallel based on the fact that the angles are congruent. So let's look at the next one. Here we have alternate interior angles converse. If two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Again, lines being parallel is in the conclusion, not in the hypothesis. Whereas before with the alternate interior angles theorem, the lines being parallel was in the hypothesis, and the conclusion was that the angles must be congruent. So these are converses of each other. We swapped the hypothesis and conclusion. So let's look at the alternate exterior angles converse. This, of course, is very, very similar to the alternate interior angles converse. It's just dealing with the alternate exterior angles. If two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. And finally, the consecutive interior angles converse. And here again, you're going to see the consecutive angles are always the standout, the oddballs in the whole scheme of things. And it says if two lines are cut by a transversal so that the consecutive interior angles are supplementary, not congruent now, are supplementary, then the lines must be parallel. So these are the converses of the four theorems and postulate we looked at with parallel lines being cut by a transversal. So what we're going to do is we're going to go ahead and prove the alternate interior angles converse. The alternate exterior angles converse proof is virtually identical to the alternate interior angles converse, so we're not going to bother with that. And then we're also going to look at the proof for the consecutive interior angles converse theorem. So let's jump in and work through the proof of the alternate interior angles converse theorem. Here's the setup for our proof. I've gone ahead and written in the given information already just to save a little time. We have two lines cut by a transversal, and we're given that angle 1 is congruent to angle 2. And we want to prove that line L is parallel to line M. So, just like with all our other theorems that we've proven, we got to come up with a general plan for how to work this and how to attack this. Now, I take a look at this and I can see that I have this angle and this angle are vertical angles. And if I note that those two angles are vertical angles, then this one must be congruent to this. And if this is congruent to this, then I know that these two angles are corresponding, and therefore those angles are congruent. And I know from the corresponding angles converse postulate that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So I can use the fact that I can show two corresponding angles are congruent to show that these lines are parallel. That's the general plan for my proof. All right, let's go ahead and start off with our first step. Now you could have done this in any number of ways, but again, it's your own style. Figure out the best way for you to think of these problems and work it that way. There's no one right way to do this. So I'm going to call this angle, I'm going to call that angle angle 3. So let's go ahead and write that in just so that we've got it for reference. And my first statement is going to be angle 1 is congruent to angle 3, vertical angle congruence theorem. So because I knew that vertical angles are congruent by the vertical angle congruence theorem, I knew that I could use that fact to write this statement. So again, all your statements are driven by the reasons. So really get to know your postulates, theorems, and definitions. They will save your life in this course. Okay, now the next thing I said we were going to do is we have to show that these two angles are congruent. And I know that they are simply because if this is congruent to this and this is congruent to that, don't we have a pattern set up here? If angle 2 is congruent to angle 1 and angle 1 is congruent to angle 3, then isn't angle 2 congruent to angle 3? What is that? Do you remember that? If A equals B and B equals C, then A equals C. If you said the transitive property, you were correct. But we can't stop there. This is the transitive property of angle congruence. Remember, we have several of them. We have segment congruence, we have equality. So there's 3 transitive properties we have. We're going to end up having 5 at the end, but you just have to highlight which one it is. So we say angle 2 is congruent to angle 3, and that's the transitive property of angle congruence. Now we only have one more step to make. Now that we know that angle 2 is congruent to angle 3, and we know that angle 2 and 3 are corresponding angles, now we can say our final statement that line L is parallel to line M, and the reason for that would be the corresponding angles converse postulate. So hopefully you didn't find that too terribly distasteful. Now let's go ahead and look at the proof of the consecutive interior angles converse theorem. And I'm going to go ahead and slide that off to the beginning of the next session. So I will talk to you in the next video.